Hi, everybody. Can you hear me? Any hand in the air? Oh, great. So I do have a few responses. Thank you for coming here in this afternoon. I know it's late and you'll be probably going home soon. And I would like to welcome you to my session, which is Sign Here. We will be talking about certificates, key stores, and other interesting things. My name is Ana Baotic, and I come from Croatia, so we're technically neighbors just across the sea. We can wave to each other at the summertime. I usually kind of tell people that we have a beautiful coast, but we all know that Italy also has a wonderful coast. So again, I need to think of something else to mention here other than the fact that we have Game of Thrones filmed at this location. I work at a company called Asseco. We do fintech, we do security, ATMs, mobile banking, and other solution for banks and financial companies. And today we will be talking about certificates, firstly, and after that key stores. So let's start from the beginning. What is a certificate? Any kind of certificate is an electronic document that proves ownership of a public key. Now, this seems simple enough, but what does it actually mean? What does it mean to prove ownership of a public key? What is a public key? What do we do with it? Well, we'll get to that, of course. It has a specific structure, so there is a document, there's a standard that depicts everything that needs to be in a certificate. And also it's used mostly in TSL, so it's secure communications between servers or with clients, and in electronic signatures. Now you know that in Europe there are situations where an electronic signature is deemed worthy of a physical one, where you can open a bank account, you can kind of negotiate opening a telecom number with just an electronic signature. And that's basically it. That depicts a certificate. But what does it contain inside? So in each certificate, you have first the identity of a host, of a user, of a person that says, okay, this certificate is mine. So it can host an address, a city, a name, a telephone number, anything that can link that particular document with you. If you're a company, again, you put information that's related to the company. If you're a person, you put your information inside. Now, it holds the identity, and it also holds a public key. Now, that public key is one half of a pair. So let's digress just a little bit. So asymmetric cryptography is something we will not be covering today, but let's just cover the basics. Asymmetric cryptography or public key cryptography is any kind of system that uses keys. Now, in our case, in the asymmetric cryptography, the keys are not the same. So we have a pair of them, but they are not identical. How do we get them exactly? So we have a large random number, and it needs to be random, that when put in some kind of method or algorithm, which is obviously not just 1 + 1 or a hash or something else, it needs to be complex, generates two keys, one deemed to be public and one to be private. Now, the calculation for these keys needs to be economical, which means that if you need a pair of keys, you need to be able to generate them fast enough in order to use them. And the relationship between those two keys is mostly determined by the algorithm that you use to generate them. Now, we won't be reinventing the wheel here because the algorithm exists. We know which ones are safe, which aren't. So your job, if you're using something like this, is just to implement the logic. Now, I said we will be using asymmetric cryptography, which means that the keys are not the same. The keys, one of them will be private and one will be public. When I say private, I do want to stress that it needs to be completely private to yourself, to your company, to the entity that it belongs to. So you cannot basically just put it on Dropbox and share the link with anybody else. And why, we'll get to that a little bit later. And you also have the public one, which you freely share among other servers, other entities, anybody you want to communicate with. So one of those keys is used to decrypt messages and one to encrypt them. Now, generally, when we talk about communication between servers and clients, the clients that will get the public key will use that key to encrypt the message that will be sent back to the originating user. The user will use that encrypted message and use their private key, which nobody knows, to decrypt it. That seems simple enough. Now, apart from encryption and decryption of messages that travel through the communication channel, those keys are also used for calculating and checking signatures. Now, this is very important because once you create something, for instance, your Android application, you are going to kind of determine the signature of that application. And you're going to do that with your private key. We'll get to that again a little bit later. So once you determine that signature using your private key, the Android system, once it gets an update for your application, will be able to check whether or not everything is okay. Mostly whether or not it is you, the developer, who provided an update to that application, and if that update belongs to you. Otherwise, it won't install. So, digital signatures are basically some kind of mathematical scheme that is used to demonstrate three things. Authentication, to see whether or not the sender is known, you as a developer, if it's really you or somebody else who is impersonating you. Whether or not you really sent that update. For instance, if you claim that your key is private and somebody receives a message that has been tampered with or is not, completely legit or needs to be, checked, then you either have your key lost or you sent the wrong message. Basically stating either you messed up or your key was lost, so again, you messed up. So that's important in the communication. And thirdly, the integrity. This means that when one person sends a message, that message is not altered somewhere in the communication channel, which means, hey, please meet me at 5 p.m. at the center of Torino. Nobody will change it and set it to 6 p.m. or 7 p.m. because they might miss the aperitivo, if I'm correctly. So that's a big deal. And now, one more thing to keep in mind here. When messages are signed, they're not signed directly. First, you calculate some kind of hash or digest because messages are variable in length. They can be short, they can be long. Text is, versatile. So in order to have some kind of standard, they are first hashed, and then that particular hash or digest is encrypted or used to send onward. In addition to that, so you encrypt with your private key to calculate that particular signature, and then you can decrypt with public key. Now you might wonder, why can we do the operations with both? There is nothing preventing you from encrypting with either of them and decrypting with the second one. It is just important that the private key and its function remain secure and that nobody can get to it except you. Okay, so we have covered the identity of a particular certificate. We have covered the keys a little bit. And now we have something that is present everywhere around us, and those are certificate authorities. So once you have your identity and you have your public key, how do we know that that data is legit? So there are particular entities in the world, more specifically certificate authorities, that claim that they have a right to prove your identity and the ownership of your key. And we trust them implicitly because a certificate authority is any kind of trusted entity that can issue certificates. Now, this is a little messed up. So you have somebody who wants a certificate and has a public key but needs an entity to prove it. How do you get certificates? If we're talking about HTTPS and secure communication online, you have certificate authorities that say that they have the right to basically create certificates. And most notably, those are, let's say, Komodo, GeoTrust, Symantec. And if you don't want to pay money, because some of them are quite pricey, you can always go with Let's Encrypt, which is a non-profit version where you can get a valid SSL certificate and not pay money for it. So those companies are enrolled in rigorous checks and programs that say, if you pass all the items, you get the right to place your root certificate in your Mac OS system on your Android device, Mozilla, Firefox, and the rest. So basically, each time you get a security update for your browser or your system, it is in your best interest to install it, because in the patches, some of the authorities or certificates might be revoked because they're not trusted anymore. And also, you might get new ones. So this is very important to keep your security up to date. Okay, and one more thing about these companies. In order for them to produce a certificate, they need to have their own. So they sign their own certificate, which is a little, meta, but they need to provide one. And since we trust them, they are given the right to create their own certificate, which is called a self-signed certificate. One thing to keep in mind here, updates are important for your OS and for your Android phone and also for your application. Because if, by instance, you have certificate pinning in your application, and let's say you, like me, have a client that tends to not share information with you at the right moment, they might opt for changing their certificate during the night, during the weekend, and on Monday morning you have 35 phone calls saying, oh, the applications are not working, what have you broken, and you haven't submitted an update, you haven't changed anything. What happened? You have pinned the certificates in the application, they have changed them, and the communication between Android, your application, and their server is no longer valid. So that's a huge problem, and as developers, it is our kind of obligation to inform the clients that they might break their own environment. So that has a huge impact. Now, back to web. If we take a look at Google, why not? You can just check it on your phone. They have a certificate on their website. And when you open it, so you just click on the little green part on the left part of the bar, you get something like this. So if you take a look at the lower part, you see that it's google.com. So obviously that domain belongs to Google, which is legit. We trust them. And below it, you have the subject name, so information about the identity within the certificate. And then after that, you have the issuer name. You see that the country is US, the organization is Google Inc., and common name is Google Internet Authority G2. So who is that? Why is Google issuing their own kind of certificate? So if you take a look at the top part, you see that there are 3 items in the chain. So let's go one step upward. Now we're on Google Internet Authority G2, and if we take a look at the data, we see that obviously the entity is Google again, but the issuer this time is GeoTrust. Okay, so Google issues their own, and the one that's issued is issued by GeoTrust. So there's a chain of authority here that is trusted. So if we go back to the root, we can see in the description of the certificate that it's a root certificate authority, and GeoTrust is obviously on the list of ones that we trust, so this is legit. Now, Android will say that it doesn't want to communicate with any kind of server over HTTPS if something in the chain is broken. So for communication to be valid, the whole chain needs to be valid and be able to check it. Now, just to illustrate it a little, you have the identity certificate, that's the lowest one, which you see, which is basically by Google. You have the intermediate certificate, which is something in between. And there is the root certificate that belongs to certificate authorities. We trust them, everything begins with them. Now, why is chaining important? Let's say that somebody makes a mistake, and let's say Google with 4 O's tries to register a domain, and GeoTrust says, okay, this seems legit, we should allow them to get a certificate. In the case of something like that, when a fake company manages to get a certificate, everything that's generated from that point onward is unsafe, it's broken, it's a branch that is dead. And basically, the whole scheme needs to be able to cut the branch or the root that is no longer valid. So that's why we don't have one certificate that proves the identity. We have a whole chain where you can manage the security properly. Now, if you take a look at the web, you see that there are 2 types of, identifying the users. You have the standard secure part with the lock, and you have sites that have their name into them. The difference between them is huge in terms of how much hoops you need to jump through in order to get that certificate. So domain validation of any kind of company is basically just proving that a domain belongs to you. So the google.com belongs to Google, Droidcon.com belongs to Synesthesia or some other company at this point. But if you have the name inside, that means that that company needed to prove additional things in order to get that name. So it's more secure. Both are secure, but the other one has more gravity in it. And also, there is a problem with domain validation where only the domain is proven. The fact that some of the probes that a certificate authority might issue, let's say it will send an email to root@google.com asking them to please verify that everything's okay or send back a token. So the check is either done by email or telephone or something else. And if that email is something that a regular user can get, we're in trouble. Something like this happened to Microsoft, I think either in Sweden or some kind of Nordic country at some point in time, where a regular user opened an email account that the certificate authority thought should have been only by somebody in charge, and he managed to get a token and do some damage, and that's a problem, which basically tells us that the whole scheme is not secure. It's only as secure as a certificate authority has the proper way of checking who the person is. So if you need to provide your users with a certificate, go for the extended validation because it's a better option. Okay, so I said the biggest problem is, you know, cutting off a part of the branch or part of the root, whichever way you want to look at it. That's called subversion. When somebody, an attacker, kind of chips away at the part of the chain and everything below it is not valid anymore, or it's tainted or tampered with, and you need to replace it, you know, throughout the whole system. So if your private key is lost, that's a problem because they can issue certificates with that private key and place fake ones. If the emails are not standardized, and they're not, then you can technically hijack, you know, the communication between the certificate authority and the entity. And also for key storage. Now, big companies won't keep their key, their private key, on a USB stick or a Git repository. Maybe they will, but you can be sure that not all of the company will be able to get it. So not everybody that comes to the company, you know, to code or to develop or to manage won't be able to get it. They will use hardware security modules, which are machines, basically machines that need 10 or 12 physical tokens and 2 or 3 people at the same time in order for them to move, do any kind of change on that module, transport it, anything. Those modules, those hardware machines are very susceptible to a change in voltage, to tremors. So if it's an earthquake, there's a big chance all data on that security module might be lost. So if you kick it, you can be sure that all the keys that you had stored there will be deleted and you will have to reissue them throughout the whole system again. So it's a big deal and they take it seriously. So your private keys, and we're talking about Android applications, I predict that you keep them in your Git repository for the project or maybe a separate repository, but sometimes that might not be enough. Okay, so Android, as we mentioned before, doesn't trust several things, which is funny if you look at the fact that the platform is open, we can do mostly anything with it. So if there is an unknown certificate authority, you don't want to pay for a commercial solution, you don't want to use Let's Encrypt, you say, I will be my own certificate authority and I will produce a certificate for my internal site. Fine. But Android will tell you, no, I will not communicate with you because I don't know who you are. So when your Android system got prepackaged with certificate authorities and root certificates, that one was not among them, and it will not trust the communication. What you could have done before Android M, or let's say about that, you could have taken that certificate and installed it on the device which is a lazy way of, pinning a certificate, but you could have done that. And in that particular case, Android will say, okay, I see that the list of certificates contains this one, let's communicate. That's fine. Also, any kind of self-signed certificate will be a problem, except for those issued by the certificate authority. And if there's something wrong with the chain on the server, you won't be able to communicate. So if you're doing some kind of remote connection to an API and having problems with this, check with the server people, because they tend to mess it up a little and change it and not notify you, and then it's all sorts of drama. Okay. Now, as far as Android goes and signatures, your Android application is signed. Your debug application is signed. Your production application is signed. Can anybody tell me the password for your debug Keystore on Android? Anybody? Okay, basically, when you create an application, at that point, you neither have a Keystore that you created, nor private key, nor anything else. But Android Studio uses the Keystore that's in your SDK. So you already have a predefined Keystore, which is valid for 1 year. And its password is Android, not really safe. The password is the same for every person who is developing. But the signatures created are not the same. They're typical for your machine and your user, and that's why signatures clash. Now, Android won't allow you to install an application that is not signed. Debug works because you have the debug Keystore in the SDK, but in order for you to actually deploy an application on somebody else's device, a non-debug build, you will need a Keystore and a private key. Now, this is something you have all seen multiple times, or if you're just beginning with Android, you're going to see it soon. It is the screen that Android Studio provides you in order to create a Keystore. Not much happening here. You need to provide a path and a password for that Keystore, which needs to be safe. Don't put just random numbers, and make it secure. You have the key, which will be used to sign that application, and within it, you get the certificate part. Now, this is where you define your identity. If you're not making your own product, you will put your company data in here. All of this data is used in order to create the whole certificate, so it matters. And also keep in mind of the validity. So Android won't allow you to create anything which is less than 25 years of length, because they're expecting all of your products to live long and happily in Google Play, and your users to be able to install them later on. Okay, so if you have the Keystore and you passed through that step before, all you need to do is decide which one you will use to sign your application. This part isn't particularly interesting. Now, if you don't want to do it like this, you also have the option to use the tools at your disposal, which are a key tool, Zipline, and YarSigner. Now, if you've ever added any kind of key in your application relating to Google Maps, you've most certainly generated a signature or read the signature from the key tool on your Keystore, because you need to add that signature on Google Play, because that's how they check whether or not communication is valid towards Google Maps. We won't go into details. Basically, Zipline ensures your application to be aligned perfectly with RAM onwards when you use the application. And you have the YarSigner that can obviously sign the application. Key tool is used for generating keys. Now, there are some decisions to make, and those decisions are really important. Who is going to be responsible for your signing key? There's one option, which is the old decision, the one we all made, 2 or 3 years ago, and that is that we, the developers, will be in charge of our particular signing key. Which means that once you've created your application, signed it, you kind of place that data somewhere in the Git repository or on a local storage, and you say, each time I'll be able to update my application, I'll just use it again. Seems simple enough. Your expectation is that each time you create a new feature or update the app, your users will be able to get that update through Google Play. Prerequisites for that is that your key is safe, so you know where it is, and also not everybody can get to it. So if your key is publicly available, the private key, you have a problem because anybody can use it to sign your application and get the same signature. Reality is that people drink and spill coffee and that they leave companies. Now, this is the part where I tell you of my personal experience, where we're going to do it more of a like a Android fairy tale. So there was a developer named John, which worked at a lovely company. He got the task to develop an application, which he did. He published it on Google Play. At some point in time, was drinking coffee. He was very clumsy, and he spilled coffee on his MacBook. Few months later, he quit his job and moved to another company. Now, obviously, he did not quit his job because he spilled coffee. We all spill things, but that's how the things progressed. And let's say half a year later, or maybe even more, the client said, okay, the application is well received, let's develop a new feature. So a new developer came to the project, they developed the feature, sent the debug build to the client, everything was great, and they said, please publish the update. And nobody could find the Keystore. Nobody could sign the application. Why? So when you try to sign the application, it requires data from you to get the certificate, obviously, and to get the Keystore. And what we come to see is basically, if you can see, store file was / something, nothing related to the project. So obviously we thought maybe this was some kind of, like a typo, maybe he pasted something wrong. And we went to Git to try and find the Keystore, and we found the log where they said Keystore data added, and that was true. The password and everything was in Bill Gradle, which is a big no-no. But the Keystore itself was nowhere. Now you had two options. Go to your client and tell them, oh, sorry, we can never update your application. Let's create a new package, or try to fix it. Now this particular story has a happy end, as that particular MacBook was left in the company somewhere in storage. We contacted the colleague, got the password, and we found the Keystore somewhere in his root home directory, which is great. But when this happens to a company that has tens and millions of users, you can be certain that they will not be happy. So if you use a very popular application, and suddenly that company tells you, oh, sorry, you need to install a new one and activate that one and place data inside, you will be annoyed because something that's so easy and simple has suddenly become problematic. So in terms of business, it's a crucial decision to know where the Keystore and the private key are and that they are safe. For instance, if you're working in a huge team, not everybody on that team needs to know what the data is and where it's placed. So keep it secure, keep it safe, keep it somewhere localized, and have a backup. Google has recognized that we have problems with this, and they gave us a new solution, which is a great solution, and that's the Google Play app signing. They basically said, okay, please give us your signing keys, we will keep them safe, and you will just add an upload key on your side. Now, the good thing here is that if you lose your upload key, you can just say, Google, hey, I messed up, please issue a new one and revoke the old one. So Google is keeping what matters safe at their premises, and you're free to, be a little more careless if that's what you like. Now, one thing you need to know, for all the users that already have existing applications that are signed and you're taking care of that Keystore and private data, the decision is permanent. So if you opt in to go there and give them your data, you can never go back. Now, for new apps, the procedure is simple. You create upload key, you just send the application, and Google will create the signing key. Now, for existing apps, you need to acknowledge that you want to get in the program because, like I said, the decision is non-reversible. The procedure is simple. We will not go through the details. Now, again, if there is a problem, Google has got your back. They will be able to revoke the old key and give you a new one. So let's say that we made a decision. Either Google will take care of the key or we will. But we need to decide one more thing. If you have multiple flavors of your application, will you use the same Keystore or not? Now, this is a business decision which you can answer yourself better than I can. But from my point, use a same Keystore to sign your debug and release keys. Because if there are 10 developers in the team and any chance of each one of you sending a build to anybody, those signatures need to match. Otherwise, the client or the user or the project manager will need to reinstall the app. And that's tedious. Nobody likes that. Now, pros and cons for the approach. Obviously, if you care about modularity or have modules in your app which you want to update separately, or you have some kind of permission-based activities, for instance, 2 applications that need to share data or be in the same process, then obviously the pro is to use, one setup for all the flavors. The cons, again, single point of failure. So Android, basically, the security on it is like a moat. The more entrances you have, the better chance of somebody attacking you. Now, the final part, which basically is what you will be using as developers, the Keystore system. Now, keeping any kind of data in your application is something that needs to be taken seriously. The Keystore system is a mechanism that allows you to safeguard any kind of cryptographic or critical data. But before you add anything to your application, a simple UML diagram that kind of helps you decide whether or not you should keep anything in your application. If it's super important and critical, if at all possible, don't keep it in your application. If it's not important, then why are you adding it to your application? It does not need to be there. So if this kind of ends up in a yes, any chance, you need to decide what you will be using. So if you have a situation where you need to keep something safe, a Keystore will keep your data safe from extraction, which means that nobody will be able to copy your data, extract it, clone it to another device, and get to it. Also, to keep in mind that key material is bound to a hardware part of your device, which makes extraction impossible. What you need to decide when you generate key pairs on your device for any kind of cryptographic data is what their use will be. So whether it's authentication, signing, or something else, you need to define what their use is. So if somebody tries to use it for another purpose, it won't be possible. Also, you can check and set that once a person unlocks their device, any kind of data is valid or accessible for the next 5 or 10 or 15 minutes. So it's time-based. You have several options here. You have utility methods, which are unfortunately available from API 23 to check whether a key is in hardware or if it's backed or enforced by some kind of secure unlocking. Now, there's also one decision to make, and that's whether or not you will be using a keychain or a Keystore. Now, if you want system-wide credentials, so you have credentials on your device that can be used for many purposes, and you don't want to add specific ones, then a keychain is the way to go. You get a system dialog that lets you choose, and that's fine. But if you want specific kind of use for a key, then you should go with the Keystore, because then you can define one per your application and not mix apples and oranges. Again, the Keystore API is available from 18 onward, and hopefully most of your applications will be able to use it. Now, code. There's not a lot of it, and we will just pass through the main functions. So if you need to generate any kind of key pair combination, you have 3 things to invoke. The get instance for a particular algorithm and the name. You initialize it with, in this case, purpose verify. You're verifying something and you're signing something, so obviously checking signatures and contents of a message. And then you generate a key pair. Simple enough, easy to check and to use. When you want to list existing aliases on the Keystore, you have just two methods. You invoke the get instance method on a Keystore, you load all the data that's in it, and then you just iterate through all the aliases that are present inside. Now, if you want to sign data, again, as simple as can be, you create a signature. In this case, this was SHA 256 with elliptic curve algorithm. You initiated the signature, and then you update the data. Simple enough, you already have the signature at hand. When you want to verify something, you get, again, the instance for that signature. You initialize it, and then you just update the data and check whether or not it's valid. So very little code with which you can do a lot. And finally, one thing to keep in mind is key attestation. If it's important for this to be as secure as possible, you need to be able to check whether or not there's a hardware-backed storage on your device, which is obviously more safe than software-backed. And one thing to keep in mind, only a handful of devices on Android 7, so that's API 24, support hardware-backed storage, which means that you don't really target a lot of users with this new functionality. And the final thing is, this is the state of Android. It's fragmented. There are so many devices, there are so many screen sizes, and people kind of tend to not update it if they can. So on Google Play dashboard, you can see that the Android O users amount to 1.1% of the whole 2 billion users. So 1.1%. Any kind of API feature that targets security or anything else, in order for you to be able to deliver to your devices, to your users, you will have 1.1% of that whole base. So when Android P comes out, there will be some new features. Obviously, if you read the preview and the documentation online, you can see that they've introduced something that's called key rotation, which if you're keeping your Keystore and key private, this kind of helps you out because you do not need to share your key with your coworkers. You can have different ones and they rotate. So a lot of you can deploy an application and not worry about it. And there's also the Strongbox Key Master, which is the hardware security module, which we talked about, that will keep your data safe. And to keep you with two final thoughts, if you want to read more about the security in its present form, there's a good glossary on Google, which they provide in the transparency report. And if you have a domain, use this site to check how secure it is. The Qualys website allows you to enter your domain, and they will give you a grade of your security. Apart from the security, you will be also able to tell you which Android versions you'll be able to communicate with, because older Android versions cannot support new algorithms, etc., etc. So this is important when making a business decision who you're targeting. And finally, it's our job to make Android more secure, and we have to strike the balance between security and availability. Again, who are you targeting? What's the user base that you're trying to get to? And just how secure things can be. And at this point, I would like to thank you for coming to my session. And hopefully, you will check some of these things out after the presentation. Thank you.